is this ball? Well, when the video is paused, we can safely and certainly say that it is around 30 feet away from the pitcher's mound and around 50 feet away from the trees. But if we start playing the video again, we'd lose the position and instead we get a momentum. But what if we want the position back? Well, then we'd have to pause the video and then we'd lose the momentum.
This issue of not knowing the position well when you know the momentum well is almost the exact same as the concept of the Heisenberg uncertainty principle. Developed in 1927 by Werner Heisenberg, the Heisenberg uncertainty principle states that you can never know the exact position and exact momentum of a particle at the same time. One of the most common ways of demonstrating this is a laser going between two objects closing in on each other. Let's say our hero Spaceman is fending off some space pirates.
So Spaceman's fighting off the pirates and suddenly one of them shoots his blaster out of his hand. With no weapon, Spaceman is forced to retreat. He runs through some sliding doors and presses the button to close them, but as they are closing, one of the pirates fires a blast that goes directly in between the doors. If the laser acts like our lasers do, it would get smaller and smaller as the door closed on it, but once it got to a certain point, it would start getting wider until the door finished closing, blocking the laser off entirely.
Why is the laser getting wider, you might ask? How does this relate to the Heisenberg uncertainty principle? Well, the equation of the Heisenberg uncertainty principle is delta x times delta p is greater than or equal to h over 4 pi. Delta x is the uncertainty in position, and delta p is the uncertainty in momentum. H is Planck's constant, a very small number, about 6.626 times 10 to the negative 34th joule seconds. As the doors were closing, the uncertainty in the position of the photons was decreasing. Once the uncertainty in position decreased to a certain point, the uncertainty in momentum, or delta p, had to increase to ensure that delta x times delta p is always greater than or equal to h over 4 pi. Now that the uncertainty in momentum is increasing, the photons of the laser are going to start veering off to the left and right. It doesn't feel right, but it's how our universe works.